Hello, Honors Algebra students. Mr. Lawrence here, and here's your next lesson. We're going to be using something called the distance formula, and it is this. I don't expect you to memorize it because it's just too easy. You're not going to have to memorize it. It's very simple on what to do. Now you're looking at this formula going, gosh, that looks complex. That looks difficult. Oh my gosh, I can't do it. You're not realizing how simple it is. Watch this. Let's switch over to this page. There's my distance formula in green. All right. Let's say I want to find the distance from point A to point B, my two red points. Well, one way would be to figure out the vertical distance, which would be what, 1, 2, 3 units, right? And then the horizontal distance, which is 1, 2, 3, 4 units. And then you could use the Pythagorean theorem, right? And so you could say, well, 3 squared plus 4 squared will equal x squared, where x is the hypotenuse in this problem. And so that'll be 9 plus 16, and that'll equal x squared. So I'll have 25 equals x squared. I'll take the square root of each side, and I'm only going to be concerned with the rad because the negative answer doesn't make any sense in this context. So x is 5. Now that's pretty easy to do, right? It's not a bad way to do it, but it's a little bit too much work if you are just given the points. Watch what's going to happen if I figure out the coordinates of point A, which would be at what? 2, 1, 2, 3, 4, 5. So A is at 2, 5. Now B is at 1, 2, 3, 4, 5, 6, 1, 2, 6, 2. And I'm going to use the distance formula. I'm going to erase this work for the Pythagorean theorem. Remember, I got x to be 5. Okay. Now I'm just going to fill in what I know. By this point of your algebra careers, I totally expect you to know that this is an x and that's a y. And I don't care which one's the first one and which one's the second one. Doesn't matter. But to find the distance, I'm going to subtract the x's. Well, 6 minus 2, and then square that answer. And then I'm going to subtract the y's. 2 minus 5, and then I'm going to square that answer. And so 6 minus 2 is 4, plus 2 minus 5, negative 3. And then d is going to equal the square root of 16 plus 25. That should look really familiar. Oops, 16 plus 9, excuse me. That should start to look real familiar to the problem I just did, which is the square root of 25. And again, I only care about the rad, the positive square root. And notice I get the same exact answer. In other words, all this green formula is the Pythagorean theorem in disguise. That's all it is. And Pythagorean theorem should be super simple for you. This is just another form of it. I mean, if you really wanted me to, I could prove it to you. I could say, well, a squared plus b squared equals c squared. And then if I wanted to get c alone, I would take the square root of both sides. And I'd end up with the square root of a squared plus b squared, and that would equal c. That's the distance formula. Now, the only difference is I have to subtract the x's to get my a, then square it, and subtract my y's to get my b, and then square it. So let's try it on a blue problem here. Okay, I've got to find the coordinates of the two blue points. Well, C looks like it's at 1, 2, 3, 4, 5, 6, negative 6, positive 2. And D looks like it's at negative 9 and 0. And so I'm going to subtract my x's. So we have negative 9 plus 6, because it was negative 9 minus negative 6, right? And the difference of the y's will be 0 minus 2. I have a little mistake there, sorry. 0 minus 2, and I'm going to square it. Okay, so the distance is going to equal the square root of, and that looks like it's going to be negative 3 squared, which will get me 9. Negative 2 squared, which is going to get me 4. And so d is going to be the square root of 13. Now, if I want to go for a decimal approximation on that, I can. Hold on one second here. Okay, so I found my calculator, and an approximation, a decimal approximation, I can't find my mouse, there it is. So d is going to be approximately equal to 3 6/10. Okay, and that's only the approximate answer. The exact answer is the square root of 13. You have to watch and see which form they want you to give. Okay, so G, looks like G is at 1, 2, 3, negative 3, 1, 2, 3, negative 3. So negative 3, and H is going to be at 2, negative 2. So to get the distance between them, I'm going to go ahead and subtract my x's, which looks like I'll have a negative 3 minus 2, and I'm going to square it. And then I'm going to subtract my y's and square it. And so then D is going to equal to the square root. That looks like negative 5 squared, which would be 25. That'll be negative 1 squared, which would be positive 1. So then D is going to be equal to the square root of 26. Now I know the square root of 25 is 5 on the nose. A good approximation for square root of 26 would probably be about 5.04 or something like that. Now I'll go ahead and get a decimal approximation, and I will 5.09, which is really going to round to 5 and 1/10. Okay, if I round to 100, it was 5.099. Okay, so either one of these answers, depending on which one they ask for. So that's all the distance formula is saying. All it's saying is to subtract your x's, square them, subtract your y's, square them, add them together, take the square root. That's it. So let's try one more example here. Let's say we had the point 10, negative 6, and the point negative 5, negative 8. Okay, well, I'm going to do 10 minus negative 5, square it. I'm going to do negative 6 minus negative 8, square it. And I'm going to break it down further. So it looks like I'm going to have 15 squared, and then I'm going to have 2 squared, which will end up being the square root of 225 plus 4, which is the square root of 229. So D is exactly equal to the square root of 229. I can go ahead and get a decimal approximation for that, and I'm going to get 15 and 1/10. So D is approximately 15 and 1/10. Pretty simple stuff. This should not be giving you any trouble. You're really just plugging it in. Some of you might have noticed that formula on the OAA. Real easy stuff. All right, that's it for the video. Mr. Lawrence signing off. Good night, everybody.